push it not the Excel version, or do it 52 or you have to do all?
Oh, that's a good question. So as far as the test corrections go, on the written test, you're just submitting, you're going to submit your original test and you're going to staple to it your rework. Okay, and then you'll turn that in. That's due Tuesday. Okay, you just bring it to class Tuesday. I'll collect on that. As far as your computer test, okay, you could submit that online. Just you can.
But is it all or none, or can you do just the paper and not redo the Excel part?
Yeah, you can redo whatever you want to redo. You don't have to do both. You can do neither. Okay, but in fact, I would prefer neither because it's less work for me. Okay, but as far as, so you can just resubmit your Excel test. Everybody should have gotten feedback on what you missed, so you can recorrect only what you missed, but you may want to do the whole thing just so that it's clear. I'd rather you redid the whole thing, even if you only missed one part of the problem, so that I can see what you're doing. It makes sense. So, and you can just resubmit that on Canvas. You don't need any special permission from me. Just add a second document. I'll regrade the second one. So, did that answer your question, Ben?
Kind of.
Okay, come talk to me after then. Emily.
So you're only doing half credit, right? Like
You only get half credit back
Okay.
if you get it right.
So let's say a question was 3, but you get
You get 1.5 points back
already.
Oh, then you get 0.75 points back. You get half of what you missed back.
Okay, the difference in the two.
The difference. So yeah, so if you got 1.5 out of 3, you can get 0.75 points back.
Okay.
And I'll just cut it
So
down.
if I, never mind.
Okay, you're good? Okay.
We don't have to say.
All right, so we good? Any other questions? Okay, that was even on video here, I think. We are sharing, right? Oh, no, we aren't. Yeah, we're recording. Okay, so we're going to talk about chapter 19, which is hypothesis test for a mean. Now, what did we talk about in chapter 18? Hypothesis test for a proportion. Do you know the difference between a proportion and a mean? Because on the last test you didn't. Caleb's like, no, I don't know. Okay? This is going to be a very critical distinction. McKenna, do you know? Sarah.
I don't even know that.
You want to listen? Okay. What's the difference between a proportion and a mean? Can you add? Do you know the difference? Okay. If we don't learn that difference, guess what you're going to? How well are you going to do on the test? 25% if you're lucky. Okay. Who knows? Sydney knows. Who's listening today? Bueller? Is Bueller here? Bueller?
Is the proportionate?
Yes. Sydney, what's the difference between a proportion and a mean?
Well, the proportion is always square categorical data.
Proportion is always categorical data. That's one good definition. So proportion, always categorical. Okay. What values can a proportion take?
0 and 1.
Okay, a proportion is always between 0 and 1. Okay. Now, if I say percent in the problem, does that guarantee it's a proportion? No, but it's 75% chance. Okay? So it's often a proportion, but we got to be careful. What would be a percent that's not a proportion? A negative quantity, a negative percent quantity, or above 100% quantity, like on the stock return or mutual fund or something like that. Okay? All right, so a proportion is always categorical. It's always between 0 and 1. What about a mean? What?
Is it quantitative?
A mean is always quantitative, okay? Now, this is going to be a critical distinction on the test, okay? So the last, what did we do on the last homework?
Categorical.
We did categorical, it was always a proportion, okay? Now, on the test, I'm going to mix them up. You've got to be able to distinguish with a proportion and a mean, or you're in trouble, okay? All right, now, let's talk about some rules for a hypothesis test for a mean. Number one, it should come from a simple random sample. Okay. Number two, they should be independent. Okay. Number three, the data should be normally distributed, no outliers. And your n should be greater than or equal to 30.
Sorry, what does SRS stand for?
Simple random sample. Okay? All right. Now, let's go through. I wonder if it would be better. Would it be better if I did this on the board or on the Excel? Board? Okay. I thought you guys would say Excel, we can't read your handwriting. That's okay. All right, so let's do an example here. We're going to go through the 7 steps, but step 3 is going to be different. Okay? All right, so now the mean SAT score in 2007 was 515 with a standard deviation of 114. An educational psychologist believes 4 years of English in high school helps students score better on math. She obtains a simple random sample of 40 high school students with at least 4 years of English and finds SAT math is 540. Use alpha equal 0.05 to see if she is correct. Okay. All right. So, yes, Laura. I mean, oh, that's a good question. What's the difference between the average and a mean? Okay, that's a good question. So now, you know what I did on the homework, and we may want to use this as a step 0. Was it useful on the homework, because I didn't do this in class the other day, but was it useful to just go through the problem and start listing out all the stuff? Is that useful? Okay. Mean SAT score in 2007, is that useful? No, not really. Was 515. What is 515? Which mean? Is that the population mean? What do we use for population mean? So mu equals 515. Okay? Turn that just a little bit. With a standard deviation of 114, what is 114?
Sigma.
Why is it sigma?
The population.
Because it's the population standard deviation. Important clue there. Educational psychologist believes 4 years of English. Is that helpful? No, it's just background information. In high school, helps students score better on math. She obtains a simple random sample of 40. What's 40? N. It's your sample size of 40. High school students with at least 4 years of English is the 4 years. No, I don't care about that. Find that the SAT math score is 540. What is 540? X bar. Why is it X bar? Because it's the sample mean, right? And use alpha equal 0.05. That one's clear. See if she is correct. Okay? Really, really good habit to get into. Should I make that my new step 1 instead of step 0? That's what it was on the homework. Why don't you just do that from now on? I didn't put that in my 7 steps, but that's really, really helpful. Okay? All right, so what's step number 1 that I gave you before? Is it categorical or quantitative? Steve, what do you think?
Oh, categorical.
Which one?
I go categorical.
You going categorical? What are the categories?
Scores. That's it.
The scores? Are the scores categorical or numeric?
Not sure.
Not sure. Should we vote? Who says it's categorical? 1. Who says it's quantitative? Okay, majority wins. It's quantitative. What's the difference between quantitative and categorical? Categorical's got to be yes, no, true, false, heads, tails. Only 2 options. Are there only 2 options for your test score? No, there's a whole bunch, right? Definitely quantitative.
So it's like a dice. There's 6 sides. Would that be categorical or quantitative?
Depends on how you're using it. Okay? More than likely, you'd probably say it would be quantitative because you're trying to add up the score. Like you're going to take a 3 and a 4 to add up to 7, right? So you're treating it as a number. So that would be quantitative. Emily.
Just so you know, on your notes, it says
Oh, it does. Yeah, it's supposed to say quantitative. Okay? We'll hire Emily and Melina to be my proofreaders. Okay? That's why you said categorical, because that's what my notes said?
What?
Is that why you said categorical, because that's what my notes said?
Yeah, but it didn't seem right to me.
Didn't seem. Okay, well, I'm glad you're thinking. Okay? All right, now, okay, definitely quantitative. Sorry, my notes are wrong. I'll try to fix that. Number 2, what's step number 2? I got it there before class today for you, though. Okay, even if it was wrong, it was helpful, right? Okay, so Elizabeth, what is the null hypothesis?
It's going to be the 2540.
What's 540?
The score.
The score. Okay, if you put 540, are you going to get it right? No. Got to put the right symbol there. What's the symbol? Mu. Why is it mu? Because it's a number. What's the better reason? Could I have put X bar there? No, because what does X bar represent? Represents the sample mean, right? And the mu, the null hypothesis, is it always about the sample mean? No, it's about the population mean. Laura. Oh yeah, 515. What are you steering me wrong for?
I don't know. I was just guessing.
Okay, it's about the population mean right there. We wrote it right at the beginning. You just said something. Okay. All right. Question?
I was just going to say, should it be 5?
Yeah, it should be 515. Okay. I was just writing what she said. We're going to vote on it in a minute. All right, so Jordan Edwards.
Yes.
Oh, I got it right today. What's the alternative hypothesis?
Greater than 5%?
Greater than 515. Who agrees with Jordan? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who disagrees with Jordan? Okay, there's more than 11 people in here. Who does not know? Okay, 2 honest people. More than 17 people in here. Jordan was correct. Good job, Jordan. Okay. Put a star on your forehead. Okay. All right. So now, what's step number 3? Find the test statistic. And along with the test statistic goes to find the value of the test statistic. Okay. So what's the equation I'm supposed to use here and why? So it must be Aaron's turn. You're not sure? I think Ashley knows. Z. Okay, give me the whole equation. Z equals, oh, you don't have your formula sheet memorized yet? You haven't done enough of these yet to get it memorized? X bar minus mu over which standard deviation? Sigma over
divided by square root of n.
square root of n. Now that I've got all this listed here, this is going to be super easy to plug in even for Steve, right? Can you help me plug him in?
Oh, yeah.
Okay. What's X bar?
540 minus
540
515
minus 515
divided by
divided by
0.05. Oh, sorry, 114. Sorry.
114 divided by
Divided by the
square root of 40. Okay. So we punch that into our calculator or Excel. If I share. By the way, I updated the answer key, so that should be now correct. Okay, so here we go. Equals 540 minus 515 equals the square root, no, equals 114 divided by the square root of 40. I'll underline it so it looks kind of like a fraction. That divided by that. And I got 1.38. Okay? 1.38696 if I want to be good, but I probably have to round that. Okay? Now, what's the next step? 4 is find the p-value. Now, I'm going to pick on Alex because I want him to do really well on the test. I don't care about the rest of you, just Alex, okay? No, I'm teasing. I want everybody to do well. Alex, how do you find the p-value?
We're doing it on Excel.
We can do it on whatever. Which one are you struggling with? Excel or both? Okay, so you can pick. I was going to let you, we can do it both ways. Okay? You can pick and we'll let Melina do it the other way. What's the question you should ask yourself at this step? Oh, come on. What would Rick do? You should know the answer to that question. WWRD. Draw a picture. What am I drawing a picture of? Mona Lisa? Okay. That wouldn't help very much. What am I drawing a picture of? A bell curve, right? Okay, Alex, what is the mean of my bell curve? 0. Now what? What z-score did I get? Okay, and that's on the right side, right? So 1.38696. Do I want to shade the left side or the right side? You sure? Okay, good. Okay, I want to shade the right side. And, oh, here, let's show this to the people at home. I forgot. Okay, so here, I'm going to go back to Sydney here. Do I need to subtract this from 1 or not? Yes? Which one?
You need to subtract.
I need to subtract it from 1 because why? It's a right-tailed test, essentially, right? Okay. Now, okay, so now that we've got that, Steve, you're leaving already, man? You're going to go watch the video after? Okay, we'll make fun of you on the video, okay? All right. All right, so Alex, let's go back to you. How do I find that shaded area? Did you want to use Excel or the table? I can't remember.
Excel.
Okay, how do you find it with Excel? We could have, but you said you were using Excel. Okay, what's the command for Excel to find this?
1 minus Null Hypothesis.
Okay, are you going to study with Jordan to make sure you got this down for the quiz on Tuesday? Huh? Okay, you better. Okay, Jordan, I'm holding you responsible. Equals 1 minus norm-s dist of what? Alex, what am I supposed to put in the parentheses?
These four.
Which one? Okay, very good. Okay, and I got a value of 0.08. Now, let's pick on Seth. So my p-value is 0.08, whatever it says here. Oh, actually, before we do that, Melina wanted to do this on the table. How do you do this on the table? Open up the table first, right? Okay. So I got the table here. It's a normal distribution, okay?
You use that C-score and round it to 1.39.
So I'll round this to 1.39. Okay. So I'm going to go to 1.39. 1.39 will be the last column, and I got 0.9177, right? That number is the white area, right? So 0.9177 is the white area, and I'm going to do 1 minus 0.9177 to get the purple area, and that equals 3280. So I got a slightly different answer. Oh, pretty close though. 0.0823 versus 0.0827. Which one's more accurate? Excel is more accurate, but they're very close. Okay, so now Seth, now that we've shown how to do that both ways, oh, actually, let's go back. We don't need to share that. Step number 5 is
Compared to the alpha.
compare to alpha. Okay, and my alpha is
0.05.
0.05, and I got a value of 0.0823 if I use the table, right? Which one's smaller?
The alpha.
So yeah, so the alpha is smaller. So 0.0823 is greater than alpha. So therefore, step 6 is reject or do not reject?
Don't reject.
Do not reject. Okay, so we're not rejecting the null, right? So, oh, sorry, I didn't know that was there. Okay, so we think my null is true then, right? Or there's not evidence against it. So therefore, your conclusion is?
There's not enough evidence.
There is not enough evidence that
4 years of English in high school.
4 years English in high school
Increases your math score.
increases your math score. Okay. Now, 0.08 is actually pretty close to 0.05, right? If I had used an alpha of 0.10, but I can't change it now, would there have been evidence?
Yeah.
There would have. Okay. So why do you think we didn't get evidence? Because it's actually kind of close, right? Why do you think there might be the reason why we didn't get enough evidence? Because it looks like it helped, right? 540 is better than 515. Why do you think? It's only 40 students, okay? All right, so maybe if my sample size was bigger, we would have gotten better. All right, let's do one more. We'll try to go a little faster this time. Okay, do you want to do this one on the computer? Okay. All right, so share the screen. Let's go here. Okay, so the CDC, Centers for Disease Control, says the mean cigarettes smoked per day by smokers is 18.1. We obtain a simple random sample of 40 retired smokers to see if they smoke less. We get a mean of 16.8 cigarettes per day and standard deviation of 4.7. Use alpha equal 0.10 to see if retired smokers smoke less. Okay, so we go through our numbers here real quick. Okay, Jordan Woods,
Yes.
let's go through here. Something's 18.1.
So that would be, so that's the mu.
Mu is 18.1. Something is 40.
That's your x bar.
Simple random sample of x bar. Is that your x bar? That's your n, isn't it?
Oh yeah, sorry.
That's your n.
16.8.
16.8 is what?
That would be the x bar.
X bar. And 4.7 is what?
That's the standard deviation.
Which standard deviation?
The sample.
Sample. So I'm going to use
S.
S. Okay. All right. So now, what's the first question? Quantitative or categorical? And we're going to pick on, we should pick on Caleb so he doesn't fall asleep. Too late. Okay, so is this quantitative or categorical data? Quantitative. Okay, good job. What's the null hypothesis? It must be Laura's turn. Mu equals 18.1. The alternative hypothesis is, Gabrielle? Less than 18.1. Why did you say less than? Smoke less. Very good. Okay, so next step is what, Ben? What's the next question? Pick the test, right? Which test is it going to be? It's going to be a z-test. Who agrees with Ben? 1, 2, 3, 4, 5. Who disagrees with Ben? 1, 2, 3. Oh, you changed your mind? Well, now we're tied 4-4. Melina, why do you think it's not a z? We know the S instead of the sigma. So this is not a z-test anymore. It is a t-test. Okay. What's the formula I'm going to use? X bar minus mu over S divided by the square root of n. Now, in order to do a t-test, what do I need to know?
sub alpha over 2.
In order to find the T sub alpha over 2, what do I need to know? Need to know my degrees of freedom. What's my degrees of freedom in this case?
39.
39. Okay, so now let's use this here. So the X bar is, whose turn is it now? It must be Amanda's turn. 16.8 minus 18.1 divided by 4.7 divided by square root of 40. Okay, we'll underline that so it looks like we're dividing. We're going to take negative 1.3 divided by here. Now, by the way, if you're using your calculator, make sure you use parentheses. It'll make your life easier, or write everything down with all the digits. So I got a value of negative 1.74. And Penzi, what am I supposed to do next? Find the p-value. Do we need to minus from 1? No, because? Okay, let's make sure when we're looking at our chart here, because remember, I think that our charts are different. Okay, now when we're looking at our normal distribution, okay, it gives you the area to the left. But we're looking at our t distribution, which gives you the area to the right. So do we need to subtract from 1? No, actually we don't. Okay, because why? Why do we not need to? Okay, notice here, all of these numbers are positive here. I got a negative number, right? I got a negative number. But what's cool about the t-test that's also cool about the z-test? It's symmetric. Okay, so even though I got a negative, I'm gonna just treat this just like it is. Okay, so here's the deal. Okay, I've got 39 degrees of freedom. I know that's really small. Okay, 39 degrees of freedom. So I'm on this line here. Okay, now here's how you find your p-value on here. Okay, 39. So I got a value of negative 1.74. So I'm gonna ignore the negative. Where does 1.74 fit in here? It fits in. Ooh, didn't mean to do that. 39 degrees of freedom. Negative 1.7 or positive 1.74 fits in between those two values, right? Okay. So what's my p-value in this case? If I'm using the chart, my p-value is in between those two values. So my p-value is in between 0.025 and 0.05. So the problem with the chart, with the t-score, you actually can't get an exact value. You have to say it's in between two values. Okay? So that's a little bit different with the t-chart. You can't get an exact value. With Excel, you can though. And Hannah, how do I find the exact p-value with Excel? I can't hear you. This is not the normal distribution, it's a t-distribution. T.dis. Do I do the left tail or the right tail? I'm doing a left-tailed test, okay? So what do I put in for x? The 1.74. What's my degrees of freedom? 39. Do I want the cumulative? Always answer true, okay? Good thing Caleb can go back and watch this later, okay? All right, so I got a value of 0.044. So therefore, did you have a question, Ashley? Just put true. Just say true. It's always true. Okay? We're just gonna make it easy. It's always true. Okay? I got 0.044. So who haven't I picked on? Emily, have I picked on you? I'll pick on you again. Okay, so what's the next step? Compare to alpha. And the next step is Greg, I haven't picked on you. What'd you say?
Oh, on that one, it's rejected.
Reject the null So therefore, your conclusion is
There's enough evidence.
there is evidence
Or that,
that
retired smokers
retired smokers
smoke less.
smoke less. Probably because they don't have all the stress of the job in school, right? This class will drive you to smoke, right? Okay. All right. Do you want me to save that spreadsheet for you? Okay. So can you tell the difference between the Z and the T and the proportion test? Kind of. Okay. Critical. All the steps that you did on the last homework, you're going to do on this homework, plus some more. Okay. So good luck. Oh, by the way, one more thing. I kept telling you I was going to give you some extra homework. It will be this weekend, I promise. For the type 1, type 2. It was really should have been last week's homework, but I've got most of it written. It'll come this weekend. A couple weeks probably. I'll ask that question on Tuesday. I'll have a firmer date for you.